In this video, we've got something very exciting in store for you, and I'm excited to teach you about it. We are talking about what are called literal equations. So what are literal equations? They're equations that basically involve way more than one variable, sometimes 2, 3, 4, 5, sometimes even more than that with the number of variables. And you're actually going to be asked to solve an equation for another variable. You won't get a numerical answer out. You'll get an answer, a variable on its own, equal to a whole bunch of other variables. And that might seem a little scary, but the key here, and I'm going to remind you of this throughout, is that what you need to do is focus on only isolating the value that you're being asked for, the value being the variable. And then any other variable or letter that you're not asked to solve for, you imagine is a number. So without further ado, I'm going to show you how to work through these, and then at the very end I'll talk to you about why it is that we even need to know how to solve out equations like this. So in this we have A equals B times H. That might look familiar because it is the area formula for a rectangle, square, parallelogram, any one of those. So A equals B times H, we're going to solve that for H, meaning isolate H, get it alone. So you've got A equals B times H. Now you're looking at this and imagining as if A is a number and B is a number. Don't even worry about what's going on that side of the equation. You're thinking, how do I undo what is being done to H? H is being multiplied by B. How do I undo B times H? I divide by B. So that B is just any old number. We're dividing by it to undo the multiplication that it's doing. And of course, whatever I do to one side, I must do to the other side of the equation. So the B's divide out, and we're left with H, which is what we wanted to solve for, is equal to A divided by B, or A over B, which makes sense. Right? If I give you that the area of something is 100 square feet, and the base is, I don't know, 20 feet, then I'd have to divide 100 by 20 to figure out what the height is. The purpose, as I said, I do it at the end of the problem, of solving an equation out first before plugging in numbers is, let's say you're using the equation to find the heights of a lot of different things. Rather than needing to plug numbers into this equation and repeatedly solve that equation again and again for H, solve it once in the beginning for H. And then you can find all kinds of numbers when you're given A and B. It's very cool, and in a later video I'll show you how we can do that with formulas. Very neat stuff. Okay, so in this one we're given that I equals P times R times T, an equation that's going to mean something in the not too distant future for you. We are asked to solve for R. How do we do that? Well, let's write it out. We've got I is equal to P times R times T, and you could look at it as multiplication like that because that's what PRT means. If we're going to solve for R, we need to undo what's being done to it. Well, what is being done to R? Well, P and T are both multiplying by R. So they're two numbers being multiplied by R. I'm going to do this all in one step. I'm going to undo multiplication by P times T by dividing by P times T. So I'll divide everything by P times T. And I'll do that to both sides. Again, you don't care what the I is, you only care about undoing what's being done to the thing we're trying to solve for. In this case, that's R. The P's divide out, and so do the T's. Ooh, that leaves us with the R, which is what we wanted. I over P times T is our answer. It's weird looking, I get it. Again, treat the variables that you're not solving for like numbers and undo the order of operations until you get the goal variable, the thing that you're asked to get alone, isolated. Now, this one says solve x minus y equals c for c. Sorry, I put for c, and you know what? As I'm looking at that, I'm thinking, it's already solved for c. Silly Mr. Grodin, that's crazy. I don't know, let's solve it for x. Man, that is some crazy error-age. Not a word, but we'll go with it. So let's solve it for x. So how do we solve for x? Well, I've got x minus y is equal to c. We want to undo what's being done to x. What is being done to x, you ask? We're subtracting y from it. So we have to undo subtraction of y by adding y. It would just be like solving x minus 3. You'd add 3 to both sides, except it's x minus y. You're adding y to both sides. And that undoes the subtraction of y, isolating x, And we can't simplify c plus y, so we just write it as c plus y, or y plus c. That's it, folks. So these are one-step processes or solution techniques for solving literal equations. In a later video, I'm going to go over how to solve 2 or more step equations that involve only letters and a couple of numbers. You'll be able to rock it.